So I wanted to go over the initial check your understanding for the sampling distribution and difference of sample means. The first thing that we need to do here is there's a lot of information here. And so in general, when I see a problem like this, the first thing I'm going to do is I'm going to kind of write everything out. So I know I'm going to have a mean for the sampling distribution of California. I know I'm going to have a standard deviation for the sampling distribution for California. So let's get that done, and we'll also write the mean for the sampling distribution for Florida and the standard deviation for the sampling distribution of Florida. So we know that the mean of the sampling distribution is going to be equal to the mean of the population. So California is going to be 10,800 and monthly mean 8,500 for Florida. That's a lot of information. And so for California, the standard deviation of the population is 3,200. And recall that for the sampling distribution of the mean, the standard deviation needs to be divided by the square root of the sample size. So the sample size for California is 16. And the sample size for Florida is going to be 9. And the standard deviation for the population of Florida is 2,700. And so if we complete those calculations, we'll see that the standard deviation for California is actually 800. And the standard deviation for Florida is actually 900. Okay, so now that we've got that out of the way, that may make things a little bit easier. So first thing is, what is the shape of the sampling distribution of the difference in means, and why? Well, it's approximately normal. And why is that? Well, we know that both populations are normally distributed. I'll say approximately normal just to make sure that we're doing what we need to do here. And therefore, we know that the sampling distributions of both are also normal. So both sampling distributions are normal. They inherit that normality. And therefore, the distribution for the difference in sample means is approximately normal. So that's a lot, but we had a couple of steps we had to take there. We had to establish that both sampling distributions are approximately normal because the populations are normal. And then we also know that the difference is normal because both population distributions are normal, or both sampling distributions are normal. So after that, what we want to do is we want to find the mean and standard deviation of the sampling distribution for the difference. And so in order to do that, we have a couple of formulas that we can use. So remember, there's some formulas on your formula sheet, but we can also use this in the fact that these are random variables essentially, and they behave in that way. So the mean of the difference is just the difference of the means. So mean of the sampling distribution of Florida here. And so that was, let's go back up and grab that value. That's 10,800 minus 8,500. And that is going to give me the means of 2,300, the mean difference, and the mean standard deviation is going to be calculated in a very similar way. We're just going to treat them like the random variables they are and use those formulas, so you don't have to use those big formulas on the sheet. So this would just be the sum of the variances, and this will be for X bar California, and this will be X bar Florida. And so we'll just take the square root of these values that we found up here, squared and added together. So this will be 800 squared plus 900 squared, and you'll end up with this 1204.16. And so there are the mean and standard deviations for the distribution of the differences. And then the last thing we want to do is we want to calculate the probability that the average monthly cost of living expenses for the randomly selected California residents is less than the average monthly cost of the living expenses of the randomly selected Florida residents. So what that would look like, if we just write it out in symbols, is the mean, the sampling distribution mean for California needs to be less than that of Florida. So that we get this expression in this inequality. That's exactly what it says here. California residents is less than the cost of the Florida residents. Now, if you just kind of solve that, if you understand that we're actually looking for that difference, we can just use the miracles of high school algebra to come up with this inequality. I just moved the mean of the sampling distribution for Florida over to the other side by subtracting it, and I'm left with less than 0. And this is actually what we need to find, is the probability of this, right? And so the way we do that is just like we always do normal calculations. We want to construct, your normal curve, and this would be mean 2300 and standard deviation 1204.16. And so I'll label that down here. And we are looking for the probability that this value, which is this distribution, takes on a value less than 0. And so that'll be the area to the left here. And so that's what we're actually looking for. Remember, you want to always calculate your z-score. And so in this case, z is, as always, value minus mean over standard deviation. And so that's going to be a really complicated formula, because it's going to be this difference minus the population mean difference over the standard deviation. But in practice, what that looks like is just value minus mean over standard deviation. And so we end up with a z-score of negative 1.91. I always really like to draw my two curves just because it's good practice and keeps me in practice of knowing what I'm dealing with. So this would be 0, and the associated z-score that exactly matches up here is 1.91. Whoops. Oh no. Let me draw this back in here real quick. All right, so this would be negative 1.91, and I'm looking for the area to the left still. And so now I'll just use the normal CDF. And my lower bound will be negative 1e99 for negative infinity. Then my upper bound will be negative 1.91 for the z-score. Mean 0, standard deviation 1 for the standardized distribution. So this will be my lower, this will be my upper, and this will be my mean and standard deviation to label my calculator inputs. And then finally, that will give us an area either by table A or with the calculator of 0.028. And that'll do it. So I hope this helped.